I'm in the process of learning all this stuff, so I knew this project was going to be a little ambitious for my skill level, but that's all I wanted to do was to create a trading bot that would trigger a swap when a certain condition was met. I used Python, Solidity, and Uniswap V3. And what worked for testing in Foundry was forking the mainnet locally with Anvil. So one of the things I didn't realize so much going into this is that trying to swap on a testnet is a pain in the ass. They usually fail because there's no liquidity or there's missing pools for these ERC20 tokens that you're trying to access. You're also trying to go on and get test funds from different places on the internet, which just adds more time to what you're trying to do. So it was a huge time suck. What we're going to do is we're just going to do a local fork of the mainnet, which will just take a snapshot of it in time. And then it uses the real Uniswap contracts, and you have the liquidity from the mainnet. There's no gas costs. You get instant testing, and it's repeatable over and over. So if you're building any sort of DeFi contract like this might save you a ton of time. So let's get into the code a little bit. I had a few different Python files that actually is the bot side of it, and then I have the Solidity side, which is the smart contract side. So on the Python side, I just have this quick code. I just pulled CoinGecko online through the URL just to pull to get the price. So that's all that this file is doing right here. It contains the logic to fetch the current ETH price from CoinGecko. So my SwapExecutor file, this is what actually executes the swap, and then the trigger bot file is the whole basically output program that you'll see the outputs in the CLI. So basically how I'm interacting with all the contracts together. I have a deploy script that I'm using, which this will be important. This is all on GitHub for you to see, but maybe I can just copy this snippet and even paste it down below with the other commands that I'll paste, because this is what I'm using when I'm doing the cast calls. It's basically, it needs these variables in your env file. It needs the Uniswap V3 router address and the WETH address, wrapped ether, and I have that listed as token in. So I'll include that down below. In my SwapExecutor.sol, this is the one that's used to execute the token swaps using Uniswap V3. So I won't go too deep into all the different code for these different files. We're just basically going to go through the testing process that I used. First, we're just making sure that our environment's loaded with Python, which I'm here, venv, so that's all good. I'm going to load all the info from my env into this right now. So with this command right here, export grep xargs, okay, boom. Now I'm going to launch Anvil, and I'm going to create a fork of the mainnet, which this mainnet rpc-url is something I already have in my env, which is my alchemy link. So that's going to be blurred out. You can't see it because that's mine. You would have to have your own and just register with alchemy to get this. Okay, so I will enter this. It's going to launch. It's going to launch Anvil. Here we go. We have 9 different available accounts, all with 10,000 fake ETH with private keys for each of these. So I will then take these and put them into my env over here. And again, it doesn't matter that I expose these because these are just fake Anvil accounts. It's not real money. But Anvil private key, I use this in my code. There's that listed there. I have my Anvil rpc-url, which is what shows up. Where is it? Right here at the bottom. Right here. Right there. These we will edit. The recipient is the actual account. So it's this account 1, and then the private key is listed for that. So the recipient is account 1. Anvil private key is the private key for account 1. And this SwapExecutor here, we will change this out once we actually deploy the contract. So now we're going to leave this terminal running with Anvil running. We'll open up a new one here, and this is where we're actually going to deploy the SwapExecutor to the mainnet fork. So first, we will make sure we're good. We will do forge build just to compile everything. Okay, that's good, successful. Now we will take this script here, which I will copy down below. We're using that Deploy.s.sol deploy script. We're going to use the rpc-url provided in our env. We're going to broadcast, and we're going to use our Anvil private key. So we're going to go here. I think it's because I need... I think I need to do this again. My environment variable. There we go. Yep. I had to load my env again. So boom, that loaded. So now here's the SwapExecutor deployed at. We're going to copy this right here because it gave us this little thing. And then we're going to go to our env SwapExecutor. We're going to delete this old one and we're going to put the new one right in there. Okay, now we need to reload our env because we just changed that. So that we'll do that. Boom. So this account on Anvil already has 10,000 ETH, but I'm just going to go through these steps because this would be what you would have to do if you were going to impersonate another account or anything like that. It's just good practice. We'll just send it some more ETH to the account so we're not caught off guard if we use too much or something like that. So this is basically going to send us another 10,000 to that address. So then now what we need to do is, because this is dealing in ERC20 swaps, we need to send ETH to the WETH address, which will automatically wrap it. So when you send ETH to, let me see here, what's the name of it? To the deposit function on the WETH token, it will automatically convert the ETH into WETH. So that's what this command right here is going to do. We'll copy this down below. Okay, success. Boom, boom, boom. So that's looking good. So now we're going to send that wrapped ETH into our SwapExecutor contract. So we're going to do that here. Cast send token in. Token in is the WETH address. We're going to transfer that to the SwapExecutor, and we're going to send that. We're going to enter here. Okay. So that's looking good. This command here, cast call token in balance of, we're just going to check to confirm that there is wrapped ether in this contract. Boom, look at that. It's in, what'll that convert to? I don't know. You'd have to look that up, but we have it in the account. Let's just say that. So now at this point, we have everything ready to go to run the bot to check the price. So it's basically going to see if ETH is above a certain point. If it is, it's automatically going to if it meets that condition, it's automatically going to swap WETH for DAI, a stable coin. So that is what it's already happening in this trigger pod. It's already happening in this main bot logic. So let's just run the command and see what happens here. Okay, clear that. So now I'm just going to run, what is that? Python bot /trigger bot.py. Let's just run this and see if it works. Boom. All right. So obviously you can tell now ETH's probably at like $4,200. You can tell a few months ago when I did this, it was just right around 2,000. So yes, it triggered the bot, account was loaded, account balance, that shows how much way we have. The current ETH price is $4,237. The condition met is ETH is greater than 2,000. It will ready to trigger the swap. It's got our token in, token out, which these are, this address right here should be the WETH address. Am I even saying that right? WETH. Fuck. Okay, yep. So then let's look back on here. My env, C2, where's that? WETH, yep. See, this address matches there. This should be the DAI address right there. 1D0F, yep. Oh, and this is the router address, which is actually the SwapExecutor. It's not the V3 router address. So it's going to swap 1 ETH, triggered, boom, 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 Anvil swap executed, and it did its thing. So with this next command, we can verify that the token out balance increased. So this would be our DAI. Okay, there's that. And then this, we can see our token in balance is 0 because we transferred everything. So everything worked. So the biggest thing is you just need to make sure that you have ETH in whatever test account that you're using, and then you have to make sure that you're funding the actual SwapExecutor contract with WETH that you swapped over. So as far as I can tell, this would get me about 90% of the way there. I think if I was going to actually start using this thing, I would just push it out to the mainnet, run a couple test swaps before I started trying to rely on it for anything. But this was basically just me trying to figure something out. Honestly, this project was a little over my head, mixing in all the different files with Python and all the interaction, and the Sepolia thing just, God, it threw me for a fucking loop. So hopefully, maybe even if you don't watch this whole video, you can just see the code, see that it's something that shows up on YouTube that like, hey, this doesn't fucking work. And you can just try it this way, and it will save you a lot of time. So the only thing this doesn't do is it doesn't show you real life gas prices. The forked state is frozen in time, so it's not 100% accurate at the exact moment that you're testing. So again, like I just said before, if I was going to push this out, I would run a mainnet test before I start actually using this full on. So the benefits of this type of fork testing is it's fast, reliable, and it's free. It's great for building confidence and testing all your different logic throughout your contracts and files. And it really helped me clarify what the fuck was going on after getting my brain scrambled trying to figure out Sepolia. So this is not meant to be a 100% polished tutorial here. Hopefully some of this made sense. I try to keep it condensed. I'll put some of the commands down below so you can copy them. It at least gives you a little breadcrumb trail to follow. This is what worked for me as I was building this project. Maybe there's a better way to do it. If so, please let me know. So if you're a Web3 developer or are starting this journey, give me a subscribe, leave a comment, like the video, hit me up. Feel free to use any of this stuff that I have listed in the video and that I have on GitHub. I'm going to have some other videos coming up soon. This project was one I did a couple months back, so it was a little bit trying to catch up and figure out what the hell I did previously. So I hope you got something out of this video, and take care.